Today we're going to be doing Friendly Chemistry, Lesson 27, Stoichiometry Problems, number 2, Practice Problem 2, beginning with milliliters of solution. And I'm going to do number 3 with you. And I recommend that even if you understood the way that these problems were explained in the book, I recommend you watch the next part of the video here, because there's a little trick that you can skip some of the steps that he gave you in the book and in the lecture. So I'm going to start here with our balanced equation. And I'm also going to point out here that for this one, it has 400 milliliters of a 1.5 molar iron 3 nitrate solution is mixed with lithium hydroxide. Iron 3 hydroxide and lithium nitrate were produced. How many grams of each product were made? So it's asking for each. So we're actually going to go through this problem twice. One comparing this to this, and then the next time comparing this to this. So we're going to have to do this problem twice, though this first part we're only going to have to do once. So it tells us here that we have 400 milliliters of a 1.5 molar solution. All right, so if we know what this big M stands for, this big M is showing us that we have 1.5 moles per liter, per 1 liter, is what a 1.5 molar solution means, right? If we know what that means, then we're able to use that to convert directly from this many milliliters of the solution to how many moles of the solution we have. And how you do that is when we realize that 1 liter is the same as 1,000 milliliters, right? So I can go here and I can go that this is equal to 1.5 moles over 1,000 milliliters, right? Milli means 1,000, MLS is milliliters. So if I have 400 milliliters of FeNO3, and I want to figure out how many moles there are in a 1.5 molar solution, I just need to multiply by this. So I'm going to go this many milliliters times 1.5 moles in 1,000 milliliters. And then my milliliters cancel. And then I'm able to just multiply this out. So actually my zeros here will cancel too, right? So then I'm going to have 4 times 1.5 divided by 10. So I have 0.6 moles in a 400 milliliter solution of this. In 400 milliliters of this solution, I have 6.6 moles of FeNO3. So now I already have my moles, right? So now I can apply this mole ratio. And I'm gonna box this guy because I'm gonna use him next time when I figure out how many moles of lithium nitrate I can produce. So here it's a 1-to-1 ratio, so that means that 0.6 moles of FeNO3 produce 0.6 moles of FeOH3. So I have that now. But now it says how many grams, right? So now I get to go and find my formula weight for iron 3 OH3. So iron oxide. So iron Fe, I only have one of them. So iron, it's down here somewhere. Where's my iron? Sorry. oops, sorry, it's 56. It's right in the middle. I'm like looking all over here. All right, so iron is 56 grams. And then oxygen, but I have 3 of them. So that's 16 times 3, which is 16 times 3 is 48. And then my hydrogen, and I have 3 of them, is 3. So 56 plus 48 plus 3 is 107. So that's 107 grams. So 0.6 moles times 107 grams per mole. My moles cancel. I have 64.2 grams of FeOH3. I'm double checking that, make sure it's right. 64.2 grams. Awesome. So now I need to do the same thing, but I'm using this and this. So my mole ratio now is different. It's 1 to 3. So 1 to 3, and I'm going to put this as FeNO3, 3 to LiNO3, right? So now I started with this many moles, so I'm going to go 0.6 moles times 3 is 0.6 times 3 is 1.8. So 0.6 moles of iron nitrate makes 1.8 moles of lithium nitrate. And so now I'm just going to convert lithium nitrate back to grams. So then lithium has, this is a 7 grams. Nitrogen is 14 grams. And then oxygen, there's 3 oxygen, we figured out over there, is 48 grams. So 7 plus 14 plus 48 is 69 grams. So 1.8 moles times 69 grams per mole. My moles cancel. Times 1.8 is 124.2 grams of LiNO3. All right, so I hope this little shortcut trick of immediately changing our milliliters to moles will save you guys some time.